Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the fuels in a single shot for each set. So, coming to the fuels, fuel can be defined as any combustible material which on combustion releases large quantity of heat energy that can be utilized for domestic purpose or industrial purpose, but fuel contains carbon as the major constituent. So simply we can represent fuel as any combustible material which on combustion releases large quantity of heat energy. And what is the major constituent of a fuel? Here the major constituent of the fuel is carbon. So fuel on combustion, especially the carbon, reacts with oxygen and results in the formation of carbon dioxide with the release of heat energy. And simply these fuels can be classified into two types. Fuels can be classified into two categories. Especially they can be called as primary fuels and secondary fuels. So fuels can be classified into two types, namely primary fuels and secondary fuels. Primary fuels means they can be called as natural fuels. So they are available in the nature. So they can be called as natural fuels. Secondary fuels means they are artificial fuels, or you can call them as man-made fuels. Again, based upon the physical state, both the primary and secondary fuels are again classified into three categories. So, based upon the physical state, again primary and secondary fuels can be classified into three categories each. So, they can be called as solid fuels, liquid fuels and gaseous fuels. So coming to the good examples of primary and secondary fuels. Good example for solid primary fuels includes wood, coal. Primary liquid fuel is petroleum, which is also called as crude oil or rock oil. Coming to the gaseous fuels, natural gas is the good example. Coming to the secondary solid fuels, coke, charcoal are good examples. Coming to the secondary liquid fuels, especially petrol, diesel, kerosene, these are good examples of secondary liquid fuels. Coming to the gaseous fuels, good examples are biogas, oil gas, etc. This is about the classification of fuels. Coming to the good characteristics of a fuel. So let us discuss about the characteristics of a good fuel. In general, the efficiency of the fuel is measured in terms of calorific value. A good fuel is supposed to have high calorific value. So, a good fuel should have high calorific value. Coming to the ignition temperature. Ignition temperature means the minimum temperature which must be supplied to the fuel to start combustion. It should be moderate. If it is low, then explosions may take place. If it is high, we have to supply more and more amount of the energy. That's why ignition temperature should be moderate. Coming to the moisture content, it should be low. If the moisture content is high, lot of heat energy will be wasted. At the same time, if at all non-combustible matter such as iron, manganese present in the fuel, that accounts for low calorific value. So non-combustible matter should be low. So on combustion, it should not release toxic gases. So it should not release toxic gases such as carbon monoxide, H2S and SO2. These are the characteristics of a good fuel. Next, let us compare solid, liquid and gaseous fuels. So now we are going to compare solid, liquid and gaseous fuels. So whenever solid fuels are compared with liquid and gaseous fuels, we can decide which of them is the best fuel. So for that purpose, we have to compare different characteristics of the fuels. So let us compare few characteristic properties of a fuel, especially calorific value, rate of combustion, transportation, storage and on burning, what type of products it is going to release. So we have to compare these 5 characteristics of solid, liquid and gaseous fuels. So coming to the solid fuels, the calorific value of solid fuels is low when compared with the liquid fuels. For liquid fuels, the calorific value is higher, and for that of gaseous fuel, the calorific value is highest. Coming to the rate of combustion, here the solid fuels undergoes combustion very slowly, whereas the liquid fuels undergoes quick combustion. And coming to the gaseous fuel, the rate of combustion is very rapid. And coming to the transportation of solid fuels, here the transportation of solid fuels is somewhat difficult when compared with the liquid and gaseous fuels. They are very easy to transport. Coming to the storage of the solid, liquid and gaseous fuels, solid fuels can be stored safely, but there is a risk associated with the storage of liquid fuels. And coming to the gaseous fuels, there is greatest risk associated with its storage. Why? On leakage, it undergoes explosion. Coming to the burning of solid, liquid and gaseous fuels, there are two types of products we can observe, especially smoke and ash. So, especially solid fuels releases smoke and ash. Coming to the liquid fuels, we can observe smoke and no ash will be released. Coming to the gaseous fuels, there will be no smoke and no ash. So, based upon all these characteristic properties, we can say that gaseous fuels is the best option for the combustion process. So, gaseous fuels will have high calorific value, and when compare all these properties, we can select gaseous fuels are the best fuels. Next, we have to discuss in detail about the calorific value. So, what is the importance of calorific value? Especially the efficiency of any fuel can be measured in terms of calorific value. If the calorific value is high, that fuel is more efficient. For example, if we consider wood, its calorific value will be around 3500 to 4500 kilocalories per kg. And if we consider the calorific value of petrol, that may be around 12,000 to 14,000 kilocalories per meter cube. And coming to the natural gas, its calorific value is 27,800 kilocalories per meter cube. From this data, it is very clear that gaseous fuels are having very high calorific value. So, especially the efficiency of the fuel is measured in terms of calorific value. So, coming to the units of the calorific value, different units one can use to express the calorific value. Let us see what are the different types of units available to express calorific value. One is calorie, other one is kilocalorie. Next, we are having British thermal unit, at the same time centigrade heat unit. So, in this way we are having 4 different units. So, coming to the calorie, calorie means it is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade. So, calorie is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade. Similarly, kilocalorie means it is the amount of heat energy required to raise the temperature of 1 kg of water through 1 degree centigrade. Coming to the British thermal unit, it is the amount of heat required to raise the temperature of 1 pound of water through 1 degree Fahrenheit. Coming to the centigrade heat unit, it is the amount of heat energy required to raise the temperature of 1 pound of water through 1 degree centigrade. So, coming to the relation among these units, 1 kilocalorie is equal to 1000 calories, that is equal to 3.968 British thermal unit, and that is equal to 2.2 centigrade heat unit. At the same time, this calorific value can be classified into 2 types. One is higher calorific value, which is also known as gross calorific value, and the other one is net calorific value or lower calorific value. So, higher calorific value means especially the gaseous products like water vapor is condensed to room temperature, and hence the total heat energy is called as higher calorific value. It can be calculated by using dulong's formula, that is 1 by 100 into 8080 C plus 34,500 H minus O by 8 plus 2,240 into S. Here CHOS represents the percentage of carbon, percentage of hydrogen, percentage of oxygen, percentage of sulfur present in the given fuel sample. And especially the calorific value can be calculated by using dulong formula. So it is called as dulong formula, and for calculating LCV or NCV of the calorific value, it is equal to HCV minus 0.09 into H into 587. That means while calculating the lower calorific value, here the combustion is done and the combustion products, especially the water vapor, is allowed to escape, and hence latent heat of water vapor should be removed, should be subtracted from the higher calorific value, and hence LCV is equal to HCV minus 0.09 into H into 587. Let us consider the conversion of wood into coal. It takes place in several steps. Initially, the wood is converted into peat. Peat is a brown fibrous jelly-like mass. Then it is converted into lignite. Then it is converted into bituminous coal. Finally, it will be converted into anthracite coal. Here, lignite is the lowest rank coal. And most widely used variety of coal is bituminous coal. The coal with higher calorific value is anthracite, and hence it can be called as highest rank coal. And especially always remember the fact that the calorific value depends upon the percentage of the carbon. So here let us compare the percentage of carbon of various fuel samples. So especially wood contains 50% of carbon, peat contains 60% of carbon, whereas the lignite contains 70% of carbon, bituminous coal contains 83% of carbon, and anthracite contains 93% of carbon, and hence the relative calorific values are: the calorific value of wood sample is 3500 to 4500, and the units are kilocalorie per kg. Coming to the peat, its calorific value may be around 5400. Lignite exhibits calorific value around 6500 to 7000. And bituminous coal is having the calorific value of the order 8300. Anthracite being the highest rank coal variety, it exhibits calorific value around 8600 to 8700. So these are the various stages involved during the conversion of wood to coal. So whenever the fuel sample is burnt, then it results in the formation of combustion products. So let us discuss about the combustion products. they can be called as flue gases. So the fuel on combustion, especially the carbon reacts with oxygen, results in the formation of carbon dioxide, and the second constituent is hydrogen. It reacts with oxygen and also results in the formation of water vapor. So here the major product is carbon dioxide. If enough oxygen is not available, then what happens? The carbon may undergo incomplete combustion and it results in the formation of carbon dioxide, which is a toxic gas. So in order to avoid the formation of carbon dioxide, we are supposed to do combustion in excess of air or oxygen. So here especially the combustion of the fuel should be done in the presence of excess of air. So in order to predict whether the combustion is a complete process or incomplete process, it can be analyzed through an experiment that is called as Orsat's apparatus. So Orsat's apparatus is highly useful for the analysis of flue gases. Especially here the experiment is done by using 3 different bulbs. One is KOH bulb, another one contains alkaline pyrogallic acid, third bulb contains ammonical cuprous chloride. So if the flue gas contains carbon dioxide, that will be absorbed in KOH bulb. If the flue gas contains excess of oxygen, that will be absorbed in alkaline pyrogallic acid bulb. If the flue gas contains carbon monoxide, it will be absorbed in ammonical cuprous chloride bulb. So by knowing the volume of the carbon dioxide, oxygen or carbon monoxide absorbed in the respective bulbs, it is possible to predict whether the combustion product is complete or incomplete. If it contains only carbon dioxide, we can predict that the combustion product is complete. If the product contains CO, carbon monoxide, we can predict that the combustion process is incomplete. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.